So if you're like me, you're probably tired of hearing about controls and all of the wonderful things that controls are going to do, and you're probably wondering why in God's name haven't they done them yet? We've heard there was a great tee-up to my presentation this morning by Mr. Brown, who basically explained how retrofitting, does not happen as fast as we thought, and all despite the fact that utilities are incentivizing controls at a really high rate. Codes are being implemented on controls everywhere in the country. And everyone is talking about how controls have come so far in terms of the technology. Why aren't we more than 1% to 2% integrated at this point in controls? If I have a product that's got the wind in its sails and people pushing it with money and everything else, and I can't penetrate more than 1% into the market, I've got a product that somebody doesn't want. I need to do something about that, right? So that's what I'm here to talk about. Now, Energy Focus has been around for 25 years. We started off, actually, John Davenport of General Electric, who still works for us. We call him Yoda. He is our chief science officer, and he's brilliant. He's been helping us all through my time there. We actually were in the military business as well, so we can make products that can withstand all kinds of EMI, and basically they're bulletproof. So our commitment to quality is very high. And also we like to do innovation in technology. So in my presentation, I want you to know how Powerline technology works and why even are we talking about Powerline technology? What is it? The advantages and the problems that we solve, which are considerable, and the limitations. So, nothing is perfect, everything's got limitations. And so the application of this product has to be used within its limitation. So we'll talk about network lighting control for the purpose of this presentation. It's basically systems of different types of products that are networked together, interconnected for the purpose of sophisticated intelligent lighting control. It's also known as smart lighting. This is a typical sort of industry growth chart that you'll see put out by any of the marketing companies that look at lighting, right? Don't be fooled by this. First of all, the dark brown line is labeled wired controls, and that includes, for example, a light mounted on a pole with a sensor wired into the light. That's not really to be a network lighting control. That's just a light with a feature. So all the dark brown, be a little wary about what that actually is. The blue is an exaggeration of what's really happening. So the blue is wireless lighting controls. And in the residential space, wireless lighting is moving pretty well. One of the reasons, we'll talk about this later, is that when you go to Home Depot or Lowe's or Menards or wherever you go, and you buy a residential lighting Bluetooth product, and you put it in your home system, how's it controlled? Well, basically, Alexa controls the light, right? And it doesn't matter whose product you buy, Alexa still talks to it. Google Home still talks to it, right? That's what I call interoperability. Do we have interoperability in the commercial space? Absolutely, we do. Right, so we'll talk a little bit more about that as we go forward. So there's 4 real continuous challenges. I heard this morning that the biggest challenge is that the ROI is not there. That is a challenge, and it's true that the ROI in many cases is not there. But it's one of really 4 big ones, and I think there's some bigger ones. The first one is the end user doesn't want. Pretty hard to sell a product that the people who are going to be using it don't want. What happened, especially in the beginning of the whole network lighting development process, was they let the engineers develop the product. And if you let us engineers, I'm an engineer, go to town on a product, We're going to have a blast. We're going to put matter transporters in that thing. And by the way, you know, the control is going to look like the cockpit of a 747 when we're done. All right, but the people who live, work, and play in this space that we're sitting in right now don't want that at all. As a matter of fact, that's going to mess them up. So the first time a group of lawyers are about to entertain a set of clients that are worth $20 million to them, and they can't get the lights to dim for a presentation, they're going to rip that system out of the wall and never use it again. So what's the takeaway here? The takeaway is, if you're going to offer a commercial lighting control system, it better damn well be either simple enough to understand as soon as you see it, or invisible to the user. That's one. Second challenge, cost and ROI. Here's something that's going on in every single lighting control / fixture installation that I've seen over the years. They take a light fixture that has a driver in it, and the driver is the power supply, right? And then they take a sensor that also has a power supply in it, and they connect it to the light fixture. So that's like having a car with two engines, one in the under the hood and one in the trunk, and the one in the trunk powers the air conditioning. I mean, what's the point? So why are we not, just using a 12-volt tap off the driver to power the sensor? Well, because the driver companies aren't on board with that yet, right? So here we are. Development costs. So the development costs on a wireless system, $10, $20, $30 million. Now, if you see a room with 100 lights in it and one control, who made the money on that job? The guy with the lights. The guy with the controls didn't make that much, right? So 100 lights, you need 100 rooms to do as much business if you're the control head. And then post-sale service. Nobody in the controls business or the lighting fixture business really thought much about the fact that as soon as you install a complex lighting system in a building, you're going to get callbacks every day. And it's not because there's something wrong with the lights. The lights are working. The controls are working as they are expected to work. But somebody doesn't understand when the thing automatically dims down to a point where they don't like it, how do they get it back up? So that's a callback. Nobody's going to sit and read a manual in a commercial building to figure out how to work a lighting system. Next, interoperability. So I buy an entire lighting control system from the Acme Lighting Control Company, and I can only use Acme Lighting Control Company fixtures. If Acme Lighting Control Company suddenly goes out of business, I have a broken building. This has already happened, right? A couple of times. Redwood Systems. Everybody know about Redwood Systems, right? Everybody will have heard of early adopters. Facebook and all these people put these Redwood Systems into their facilities. Redwood went down. Facilities got to be reordered. One of our competitors thought they were doing a really cool thing by using 3G cellular to actually run their system, which was a good idea because if your internet goes down, you got problems. But with these guys, the internet doesn't matter. Good idea until, Verizon decided that 3G was obsolete. And now all the buildings using the 3G system have been turned on. Reliability and security. Wireless systems can be hacked. The government will not use a Bluetooth system. It's a hack point. As a matter of fact, we sell to naval ships, and naval ships can't use wireless, even besides the security issue. They can't use wireless because they are bathed in EMI and radar. And can you imagine what that does to a network system? If you go to Lightfair and try to operate your display lights at Lightfair with a wireless system, you find that there's 500 other people in the room doing the same thing and your system doesn't work anymore. So there's challenges, right? Here's the different types of network lighting control that we see out there. On a wired side, we have wired and wireless. On the wired side, we have 0 to 10 volt. We got Dolly, DMX, phase cut. We got power over Ethernet, which is an interesting one. We thought that was going to be big, and we were wrong. And then we got Powerline Communication, which I'm going to talk about today. On the wireless side, Zigbee, Bluetooth, Wi-Fi, and cellular. Okay, again, let's pay attention to the challenges and see how those challenges apply to these different types of systems. All right, so any kind of, let's talk about faucets and brains. Any kind of lighting control system actually can be just simplify it down to these two concepts. You need a faucet and you need a brain. So the faucet decides how much current is going to go through the LEDs. And you turn the spigot open, you get more brightness until it reaches full brightness or full on. You slightly lower the faucet and you can dim the light. Okay, so you need a faucet. Now, if you put the faucet at the wall, that's great, but it can only dim the fixtures that are connected to it all at the same time. You can't individually control a fixture. Right? Part of what you want to do for daylight harvesting and stuff like that is to individually control a fixture. So really what you want to do in a sophisticated system is get the faucet out of the wall and put the faucet into every single light. That means now that you need a brain at the wall and a brain at each faucet so they can transmit messages. And when we're talking about a brain, we're talking about an IC chip that can decode messages and send messages, right? So now you're sending information. You're not just playing with the voltage and the current, you're sending information. So if you're going to send information, you have to have, here's the real challenge, right? You have to have a way to connect everything so that the information can flow. So how do you do that? Well, you can do it with control wires and physically connect, just like 0 to 10 is a way of doing this, right? You're sending information over control wires. But if, there's some cases where maybe there's no control wires pulled yet. So you're going to have to go in and you have to spend money to pull the control wires. Maybe it's concrete construction, really difficult to pull control wires. And this gets more and more complicated. So how else do we do it? So actually, this is just my little animation of adding 0 to 10 control wires to a typical lighting system. Okay. You can do this 0 to 10 volt dimming, Dolly, power over Ethernet. So you have the cost of wiring, and you have some limited capability here because you're not really messaging when you're doing this. Again, you're just sending a very rudimentary signal. Okay, another way you can do it is to go wireless, and that requires you to put you want to send a digital signal, you have to put a little radio into every single one of the components in the system. There it goes. So you got a radio here, radio here, radio here, and radio there. And this gets a little expensive. It gets a little complicated. The nice thing about it is that you're almost unlimited in the amount of information that you can send back and forth. So now you can get your lighting system to do some complex stuff. But again, be careful about adding complexity because we heard what happens before. When you add complexity to a system, things get funky. The end user gets really a little bothered by that. Okay, and that Zigbee, Bluetooth, Wi-Fi, they all do the same thing, they're just different methods of doing the same thing. And I had a great little video for you, but we can't get the sound to work. So basically my video says that the number one issue with wireless is reliability. When you have a switch and a bunch of lights that are wired together, and you press the switch, and one of the lights doesn't work, or all of the lights don't work, or whatever, it's a really easy troubleshoot. Either something's wrong with the switch, something's wrong with the fixture, or the wire is loose or disconnected, right? That's it. When you have a Bluetooth system, and all your lights are on that system, and you press the button, and the lights don't come on, maybe it's because your lights forgot that they were supposed to be in a relationship with the controller, and they need to be reintroduced. Maybe it's because there's interference in your system, in the environment. Maybe it's because your hub went down. Maybe it's because the internet is not working. Maybe you didn't pay your bill to keep your network on. All right, so the troubleshooting is a whole different thing. And when you're in your house and the lights don't pair correctly, what do? You pick up the phone and call customer service, and you sit there for a while, or you reboot your hub, and you play around, and you have to pair everything up again, and it takes you 20 minutes, a half hour, but your house is working again, because you put the time, right? And that's fine for residential, I suppose. It's annoying. But if you're a prison, or a school, or a hospital, that's a disaster. That's a disaster. So, there's a lot of reticence to put a sophisticated wireless control system in a prison or a government building, because security is the others. The government building, they will not use it. We get past this, there we go. Look at this. Go on the internet, type in how to hack a Bluetooth system, and you will get an online course. Wi-Fi, no problem either. Okay, you get a certificate probably with a diploma if you want. Is that you? All right, so what's the solution? So I'm going to offer a solution that most people have not seen. It's Powerline Communication. And in Powerline Communication, we realize that we need to interconnect everything, but everything's already interconnected by virtue of the black and white line and neutral. Problem is, that's supplying power. So how do we do this? We need to get a very complex 16-bit digital signal over that line. And this has been done in the past. We are not the first ones to do this. There are other systems that have done this. But the problems that came up were difficult. So, here's the benefits. Number one, we have the reliability. This is a wired system. We don't have to worry about any of the EMI interference stuff, the unpairing, all that crap. It's just not involved here. Okay, so number two, security. Number three, interoperability, and I'll tell you how this can be addressed in a few minutes. And then finally, cost. The cost of the system, I'll tell you up front, is low compared to any of the other systems. So why isn't everybody doing this? I'll give you a brief explanation. Is this thing going? How much time? Yeah, it doesn't matter. Somebody can tell me when I'm getting to the end. Why isn't there? So it's actually, what's that? Okay. It's actually, there's some technical challenges to this that are difficult. Now I'll explain those. Number one, here's your 120 volt AC line, 50, 60 hertz. Okay, nice sine wave. There's a digital signal, 5 volts, and it's just a square wave. And you think to yourself, I can just ride that square wave on top of the sine wave and have a filter on each end to figure out that these little glitches are the actual messages, right? And that's a great idea, and that's how some of the older systems did it. Here's the problem, though. This really nice sine wave doesn't actually look like that. It looks like this. There's all kinds of hash on that line. Every time you turn on a machine in a commercial building, this becomes even worse than that. If there's EMI, if there's bad grounds, if there's a million reasons why it's always going to look like that. So how do you figure out which of those glitches is a signal and which is just noise? You can't. You put a modulator, demodulator on each end, and it costs a fortune. And it's not that reliable. So, what do? We do it differently. We actually go into where the zero crossing is on that 120 volt line, and we take a little piece out of it, very deliberately. Not enough to change the amount of power that's going to the product in a significant way, but enough so that a decoder on the other end is going to see that glitch and know that's a glitch. I mean, that's a deliberate glitch. That's not a little hash on the line. As a matter of fact, to make it even more reliable, we will do 4 of those in a row before the controller on the other end actually responds. When it sees 1, it says, oh, this might be a message. When it sees 4 in a row, it says, this is definitely a message, and it waits for the next 16. The next 16 are going to be the digital message that we're sending. And all we have to do is change the width of that little glitch to tell it whether it's a 1 or a 0. It's very reliable. It works every time. It gives you the reliability, the security. I'll talk about the interoperability now. So, you know, we need a brain in each one, and we put a brain into every one of our fixtures, and a brain into every one of our controls. And those two talk to each other, and they talk their own specific language. Okay, but what if we wanted to just control a 0 to 10 volt commercial fixture? Well, what we have is a little module. Whoops. This is supposed to be animated. No, it's not animated. But anyway, this module takes a signal from our controller, translates it into dual 0 to 10 volt out, and now you can take that little module and put it in any commercial fixture that works on 0 to 10, which is almost any commercial fixture. So now it's a very low cost little module. It'll fit in the driver compartment of something, of any fixture, and we can offer it to anyone who wants to use it for the fixtures that are already set up in the building. And it can do color tuning. It can do circadian rhythm control. It can do just on, off, dim. Just by virtue of the fact that you don't have to pull 0 to 10 volt wire in a school or something like that, this module just plugs into the wall. I'll show you what it looks like. It's about the same size as a single gang switch. Does dimming, color tuning, on, off. It can actually do scheduling, things like that. Later versions of this will do a lot more, to the point where we are hoping to get it to Title 24 compliance. But we don't want to get too complex. We got to be careful again, if we run into the customer doesn't want it issue. So what are the limitations? So one limitation is the fact that that sine wave is 120 hertz. That means 120 of those little glitches per second is the maximum that we can send. Our first versions of this were a little bit slow. I don't know if you've ever seen it. What was it? The movie Arthur or something, where the guy was saying, instant on lighting. Look at this, instant on lighting. And he's trying to sell that as part of the apartment. It was embarrassing. If you turned it on, it took about a second before the lights came on. Now, a second doesn't seem like a long time, but it will drive you crazy. As a matter of fact, you'll turn it on and you'll be like, oh, you'll hit it again, and now you just turned it off. Okay, so you could be there for a half an hour trying to figure out what's going on. We're faster than that now. We're imperceptibly fast, but it's still slow. We're not going to be streaming Netflix over Powerline Communication anytime soon. Put it that way. We can't really send a ton of information quickly. But if this is a single room configuration, you've got everything you need. So the other thing is that we can't jump circuit breakers or other obstacles, transformers, and things like that. So we can't create a full campus network situation. And again, people came after us and said, well, how are you going to do all this, zoning and everything that you need? You know what? Not everybody wants to do that. If the driving force is to put circadian rhythm lighting into an assisted facility guest room, this does it. Nothing else really does it that well. Okay? And there's about a ton of other applications. which I'll tell you right now. There's my timer. I'm going to be done soon. Difficult, expensive wiring situations. Maybe this house has already been built, it's all concrete walls. How are you going to run control wires through that house? How are you even going to get Bluetooth through those walls? You're not. But this system will work beautifully in an application like that. Prisons and government buildings. No security issues. No hackable situation. We worked with the Navy. When the Navy saw this, their heads spun around because they were like, wow, can we finally dim lights on our battleships and not get shot out of the water when we're in enemy territory? Can we actually do that? And the answer is yes. It's going to take us a couple of years to get us into those ships because you have to pass mil-spec standards, which are kind of like, trying to get something to the moon, but we'll do it. High interference applications. Those are conning towers on ship. That's a conning tower on a ship. Can you imagine what that does, to a Bluetooth system or a Wi-Fi system? It's just not going to work in that environment. Ours will. And multi-functionality. Here's a really interesting one. Because we're sending messages back and forth that are sophisticated messages, we can tell if there's a multi-function in one device by sending different messages to control the two functions. So if you've got a ceiling fan with a light in it, right now in a residential situation, the big pain in the neck with a ceiling fan with a light in it is to control both of those from the wall, you have to pull a second set of wires. With our system, you just plug in our little switch there, and it will be able to control both the light and the fan independently without having to pull wires. Or use the remote control. Yeah. So, and that's like a UV plus white light. We could do the same thing with that. We can control those independently. So that's it. Any questions?
So,
yes.
Is it like similar to DMX where each component has like an address?
Yes.
Great, thank you. Before we go any further, Brian, would you take the panel's chair? And you gentlemen, if you could share that microphone, I don't know where our audio guy went.
Oh.
It's probably be a
All
shame
right,
to
sure.
get the
All
audio
right. All right.
video. Okay, sorry, please go on.
Oh, what can go wrong?
That's a great question. What can go wrong? We've got about $1 million worth of systems installed right now. We have no callbacks. That's great. So I imagine that something can go wrong, but we haven't seen it. Yes, sir.
Powerline has been around forever. You're doing it different. Is anyone else using your type of recipe that you know of?
Please let me know if they are, because we have IP on this. But no, we haven't seen it.
Similar?
I'll admit something. I was at Leviton for 12 years, and for 8 of those 12 years, we tried to make this work, and we couldn't because, I only gave you a smidge of what's difficult about it, but they couldn't do it. So when Energy Focus showed me this, I was consulting at the time and semi-retired. I came back to work because I saw it work, and I said, "Oh my God, you guys did it!" So go ahead.
I got a question for Brian. Brian, have you sold any network lighting control systems, like major into new places? Have you had any problems? I want to hear what a distributor has to say. Have you done that?
I have. The main one, the Lutron Vibe system, we've done on some large campuses. You got the obviously cool 10 volt, use power packs for your zoning. The main problem has been some of the updates, not communicating with the highly secure campus. So Lutron working with the IT department has had some difficulties. We use also Bluetooth systems and stuff like that. But okay, we have some callbacks as far as making sure the zoning's right, things are paired or unpaired. But my question to Greg is, how easy is to add daylight harvesting or occupancy functions to your Powerline Communications product? to me, it seems like a pretty good product.
Thank you. It's a great question, and our product as is right now doesn't do that, but it's here's the plan for that. And Focus 2.0, which we're going to release first quarter next year, will have a small Bluetooth device in the controller that will talk to a peel and stick sensor. So all the sensor does is say, I've just sensed something. It sends us, I sensed something message. Our little Bluetooth thing will hear that message from the peel and stick sensor and then control the lights accordingly through the power line, right? So adding that little Bluetooth will allow you to understand sensors, to do daylight harvesting, all that stuff.
So essentially, once that 2.0 comes out, if you have say a conference room with 2 circuits, maybe can lights and maybe some choppers, you'd be able to add your 0 to 10 volt modules on each fixture, and then put in your wall switches, and then add occupancy to the zone.
Yes.
Easily.
Yes.
How about if you don't have 0 to 10 fixtures? What happens if you have a combination of 0 to 10 in your room as well as you got magnetic voltage, you've got a combination of different lights?
That's difficult. I mean, now you're in a situation where you're going to have to go in and either retrofit or change something, or run pull wire or something like that. But I mean, our system will handle anything. You have 2 choices with our system, and I think any Powerline control system. You can buy lights from us, which understand our signals already built in, and we can actually build in custom lights for you. And the advantage there is that they're a little cheaper and they'll be very tunable smoothly because we've done all the dimming curves and everything else. Or you can use our 0 to 10 volt conversion module and then just connect to any 0 to 10 volt product. And you can do a combination of those as well.
How easy are the modules as far as like if you have existing fixtures, you said you just place it do they you just lay it in there and it just
Yeah, they connect black and white and black and white out.
so that's pretty
Like, is it like it seems like a niche thing for you guys because if no one else is doing it and you're not willing to share the IP, it's probably gonna be dead. In my opinion, you've got to have lots of different companies making this kind of Powerline stuff.
Oh, we are willing to share the IP, but not for free.
Yeah, so but I mean, it's like I think that's a mistake. I think that's a strategic error. Because if you guys are the only ones talking about it, I don't think it's going to go anywhere. I don't know, Brian. I mean, you're on the panel too. I mean, are you going to really in 2022 go with a sole vendor on a lighting control system that, that only they can fix it, only they have the parts? I mean, that's part of the problem is that there's, you can't just have one person that can be able to address the equipment. If you do that, you're in trouble. That's one of the major barriers to entry. I don't know, Brian, what do you think? Is that the equipment doesn't work with each other's gear. And if you guys are specifically going after that, I think it's a mistake. I think you should somehow give away the software for free so other people can make stuff for it. And,
Well, it's software and hardware.
Yeah.
So we were willing to work with other manufacturers and we're willing to license out to people like Lutron, Leviton, any of those folks. Or even anything else. And there's room within the cost to actually, float the license. So we think, it's possible to do this. But well, first, Mr. Brown.
Can you talk about GSA about them expecting this for their protocol?
We are just talking with them now. Yes.
Question about commissioning, so when the first power system was out back, what it's talking to?
Yeah. In the case of on-off dim only, and we sell a lot of systems right now that people just can't pull 0 to 10 volt wires, so they're just doing on-off dim. So we have a unit that's configured only for on-off dim. We have a second unit that's configured for doing circadian rhythm and color tuning. That one requires you to press a button once, twice, or 3 times, depending on what time of day it is when you first turn it on, so that it knows where it is in the cycle of the day. And then from then on, it tracks, and it knows where it is, whether you turn it on or off or dim it or anything like that, it still knows. Right, so those are the only commissions.
So how does it know how much the room you're in or the next building?
So we're not crossing rooms with this system. So,
I mean, if I'm powering up this room and that room next door is also got the same system, are they gonna wanna talk to each other sometimes if they're on the same circuit?
no, you're gonna have to go Bluetooth for that. Oh, if they're on the same circuit? No, because only the load side is actually communicating. So if I've got a switch controller here going to these loads, and another controller going to loads on the other, in the other room, they're not gonna cross talk.
We have to have a neutral.
You don't have to have a neutral. However, if you don't have a neutral and your ground is not good, you're in trouble. So we have 2-wire and 3-wire versions of this. The 3-wire version doesn't matter how good the ground is in the building, because we'll use the neutral for the reference point. But if you have a bad ground and you're using the 2-wire system, that's going to give you problems. So you got to make sure you're grounding. We have a little device we're coming out with that will allow you to just check the ground, and we'll send a signal and see if we hear it. And if we do, the ground's good enough.
How about 277?
Yes. It's where it's currently configured for 120 to 277 on that. Holding it.
When you all work with Japan, how many different voltage and cycles?
We can do 120 to 270, 750, and 60 hertz. If you needed to go down to 100 for Japan, we could probably test it or configure it so that it would work.
Okay.
Yes.
You said that you could, on a single switch, that you could switch like a fan load, is it that way from a light load? Would that would be like an AC motor fan and not an AC motor fan? Or?
So we're actually working on that product right now. I don't know the exact answer to your question. Certainly an AC fan, it would work, and I'd have to get back to you as to whether an AC fan would work. It's a little bit of a challenge on how much amperage we can control the fan speed on, because it starts to heat up and we're stuck in a small box. But we're working that out, and pretty soon we'll have one that works very smoothly.
What about TLEDs?
TLEDs? Yeah, if the TLED we have TLEDs that are configured for us. As a matter of fact, that's our main product, is we're selling TLEDs that talk to the controller.
We have time for one more question, please.
I have one question for you,
There you
Gary.
go.
Your fixtures are coming embedded with your technology, or a lot of these offered with the circadian rhythm and color tuning option.
Yeah, so when we come out with fixtures, and we've got slim down lights, we've got LED tubes, we've got some panels that we're about to release, and some commercial downlights. Those come in 2 versions. They come in dim only, and they come in color tunable and dim. So you can choose either one. One's a little more expensive than the other.
Thank you.
All right, great.